Hello and good day, geometry. We are wrapping up our unit on quadrilaterals with one more quadrilateral we haven't talked about yet, and that is a kite. And a kite is different from a parallelogram. It's different from a trapezoid in that it's the only quadrilateral we're going to discuss that does not have parallel sides. 0 pairs, right? Parallelograms, rhombus, square, rectangle, they have 2 pairs. Trapezoid has 1 pair. Kite has none. So, what does a kite have? Okay, give me a property that you might know of about a kite, Sebastian.
4 sides.
It does have 4 sides. That's why it is a quadrilateral. You are correct. Brent.
Can I get a piece of paper?
Oh, that's right. I printed. Yeah, sorry. I have it here. I just didn't give it to you. Sebastian.
There are no parallel pairs.
There are no. My cord got caught on something over there. There are no pairs of parallel sides. The kicker is I have to post this one because Monday did not go well at all. So, whew. All right. Now, yes, also true. There are no pairs of parallel sides. That's what a kite doesn't have. I want to know what a kite does have. What are properties of a kite? And I'll tell you if you want to stop guessing. I mean, Brent. What?
I know fly.
They cannot fly. Not. Ugh. Linnea. They do have congruent sides. They have 1 or 2 pairs of adjacent congruent sides. Other shapes that we've talked about here, we've got rectangles that have opposite congruent sides, rhombuses have opposite congruent sides, and a square. A kite has 2 pairs of adjacent congruent sides. So an example of this first characteristic here, kind of draw our kite, looks like, kind of draw it like that, I think. Okay, the pairs of adjacent congruent sides, 1 pair and 2 pairs. Okay, the congruent sides actually touch at a vertex. They're not congruent to, like, all 4 aren't congruent. That would make it a rhombus or a square. But for kite, you got 2 pairs of adjacent congruent sides. Good, now we're getting somewhere. Number 2, Sebastian.
It has 1 pair of congruent angles.
Yes. Okay. It has 1 pair of opposite congruent angles. And so we're going to draw another kite to kind of show this property here. So let's kind of make this a little wider at the top, narrower at the bottom, like that. Okay. In green, I'm going to put what we already know. Because it's a kite, we already know we have the adjacent sides here. Being that it has only 1 pair of opposite congruent angles, we have to know which pair that is. And it's the pair of angles in between the congruent sides that will always be congruent angles. And we can verify this, we can validate this using a theorem all the way back from CO32. Do you remember what theorem would prove to us that these specific 2 angles are congruent? Linnea? That's more for like parallel lines and angle relationships. CO32 was the Hinge Theorem, if you remember that. Angles that are formed by congruent corresponding sides, like we have here, have to be congruent. Okay, because they're formed by sides that are corresponding congruent sides. And number 3, what's the third property of a trapezoid? Anybody know? Sebastian.
Let's see here.
Okay. Thanks for trying, though. It has to do with the diagonals. The diagonals of a kite, the diagonals are perpendicular. The diagonals are perpendicular. So drawing one more kite showing this property here. Let's have our kite be opening or like vertical more this time. Kind of like, well, that's not a very good kite. But the diagonals connecting the opposite vertices, they are perpendicular, okay? Which means we've got a whole bunch of right triangles inside of a kite, which means right angles. So Pythagorean theorem, sine, cosine, tangents, 45, 45, 30, 60, 90 triangles, they're all going to come back when we deal with kites here, okay? Questions on that thus far? Okay, so CO50 is 2 pages. The first page, we've got the notes here, and then we practice finding some angle measures down below. The second page focuses on finding side lengths, basically, with the diagonals. So for each kite, each of the 3 here, we have to find angle G. And each one requires a little bit different thought. What's our game plan here for looking at this first kite and finding the value of angle G? What do you think? Brent?
Add 140. Wait. No, I did that wrong.
No, you're on the right track.
Oh, add 140 to get 148. Minus that from 360.
Okay.
And then divide by 2.
Good. So the first thing to remember here, we're dealing with a quadrilateral. All quadrilaterals have 360 degrees in them. Okay, so we know what we have to get to. So we start with 360. We can subtract, as Brent said, 140, because we already have 140 degrees spoken for with 2 of the other angles. So 360 minus 140 equals 220. And then Brent said we're going to take that 220 and divide by 2. Why would we divide by 2? Julia? Right, we have 2 angles left to split that 220 degrees with, and we know they're congruent, right? So they'll be the same thing. So 220 divided by 2 is 110, and that would be your answer, your value for angle G. How about the next one? What's our game plan to find angle G in the next one? Elise?
You subtract 60, 110, and 110.
Right. The nice part about this one is angle H here. We know it's congruent to angle F, which means that that's 110 as well. So we have 3 of our 4 angles. We know we have to get to 360. So 360 minus 110, minus 110, minus 60. My math comes up with 80 degrees. Is that correct? Good. Whew. And the last one, how about this one? Only 1 angle given. Right, Linnea?
No, but there's the box that shows that there's a right angle, so it'd be 90 degrees.
Right. So kind of similar to the first one. 360 minus 150 minus 90. That leaves us with 120. And 120 divided by 2, since these 2 angles are congruent, E and G. Angle G is 60 degrees. Questions on that? Okay. What similarities do kites have with parallelograms? They have 4 sides. They do have a pair of opposite angles that are congruent. Parallelograms have 2. These have 1. That's a somewhat similarity. Also a difference. Difference doesn't have any parallel sides, rather than opposite sides being congruent. It has adjacent sides that are congruent. So we kind of already talked about those things there. Diagonals are perpendicular. That is similar with a rhombus and a square. So a couple things. All right, the back side, or the second page, which is admittedly a bit more difficult than the first page. First of all, take the time to perhaps, I don't know how well it copied off in your binders. Some might be better than others, but each of these kites do have the diagonals drawn in here. And that's kind of important to know to answer these questions. So if you need to trace over the diagonals so you can see them better, do it. Otherwise, if you just know that they're there, that's fine too. But for each kite, I ask you to find 5 different pieces. Okay? WX, XY, YZ, WZ, so 4 sides. and then angle WXZ. Seems daunting, but what do we know about WX and XY? In the spirit of Christmas. Julia. They're congruent, right? WX and XY are congruent sides. So if you find one, you know the other. How about YZ and WZ, Sebastian? They're congruent sides as well. So it sounds bad, but not really. You only find 3 values because the other 2 are given to you then with the congruency. So let's start with WX. Tell me what you know about this figure that would allow us to solve for WX. Side WX. Sebastian.
It's a 45, 45, and 90 triangle. So that means the 2 sides are like 3. The hypotenuse is going to be 3 and square root of 2.
Good. How do you know it's a 45, 45, 90 triangle? Yeah.
Because if there's one 90 degree and the other 2 have like 2 equal congruent legs, then that shows that the angles are also going to be congruent.
Yep. We know we've got right triangles in here because the diagonals are perpendicular, so we got a right angle there. Focusing on this triangle, Sebastian's saying he's noticing that the 2 legs are the same thing, 3 and 3. That's the definition of a 45, 45, 90 triangle. So he's going back to his special right triangles, and he's saying, well, that hypotenuse then has got to be 3 root 2. It's the leg length times root 2. So WX is 3 root 2. Are special right triangles the only way to answer this question? Julia? You could use the Pythagorean theorem. What do you come up with if you get the Pythagorean theorem? Or if you use that one? Linnea?
No, not 8. What the heck? Yeah, never mind.
Okay, Elise? The root of 18. Yeah. Normally, when you're doing this objective, you've already had algebra and already covered how to simplify roots. We did talk about this a little bit. It does say to write set answers in simplest root form. However, I would accept either of those things because they are equivalent. If you were to simplify root of 18, remember that involves finding that perfect square factor, which is root 9 times root 2. Root 9 becomes a 3. The root 2 just takes along. Right? So if you use the Pythagorean theorem here and you leave it as root 18, that's okay. What I don't want, though, is a decimal. Okay? Leave it in root form, either Pythagorean theorem or 45, 45, but not a decimal. And if WX is 3 root 2, then XY is also 3 root 2. How would you go about finding YZ? Sorry, there's no easy side to find. No. Linnea, how do you find YZ? For this one, use the Pythagorean theorem. There's no special right triangle we can use. And so 3 squared plus 5 squared equals c squared, and you'd work it from there. Okay? And then WXZ. WXZ is this angle here, going from point W to point X and down to Z, so this angle there. We already talked about the fact that this is a 45, 45, 90 triangle, so obviously it's 45 degrees, okay? But let's go down to the one below this, where WXZ, angle WXZ, this angle right here, is not part of a special right triangle, right? The leg lengths that make up this angle are 4 and 6. Not the same. How do we calculate that angle measure? This is also from your previous unit, PO43, in fact. Somebody new? No? All right, Sebastian, your hand was up first.
So if you're doing WX Z, you don't have to do that whole triangle. You can do the top part. Because if it's a straight line, it's a 30, 60, 90 triangle.
Ooh, How do you know it's a 36, 90 triangle?
Oh. Never.
Okay, yeah, there's the relationship between the two legs of a 30, 60, 90 triangle. If our short leg was 4, our long leg would have to be 4 root 3, not 6. So Elise, what were you going to say? Yeah, the inverse of sine, cosine, tangent, right? From this angle, the one we want to find, what's the location of the 4? Is it opposite, adjacent, or hypotenuse? Opposite. From this angle, the one we're trying to find, what's the location of side 6? Adjacent. What ratio involves opposite and adjacent? Tangent. And since we're finding an angle, it's going to be the inverse of tangent. Opposite side over adjacent side. Make sure you have them in the right order. Opposite over adjacent, which ends up being, you can round this to the nearest degree. It's 33.7, so you can round it to 34. Okay? So, anything that we learned last unit dealing with right triangles is in play here. Pythagorean theorem, sine, cosine, tangent, special right triangles, all of those tools are at your disposal. Okay? Questions on this? Schedule moving forward for this unit. You'll get your practice test tomorrow, and then next Wednesday after school will be the test for realsies. If you can't make that, then come talk to me and we'll figure out a different time for you to do it. But after this, we got 1 unit left, and once we're finished with that one, then we're done. So there you go. The end is near. Okay? All right, folks, that's how you math.